AP Calculus AP Calculus BC, Unit 5, Day 1, Office Hours. Here are the answers. You should have checked them already online. I'll just put them on here real quick. So pause the video if you need to check your answers. Number 5, I don't know if I corrected that online, but it shouldn't have absolute values for the final answer. It should be in your work. So there's that page. And here's the next page. So here are the answers on the next page. And that's my dog barking. All right, so this is pretty much an integration review from Calc AB. So usually we try substitution. Now, I don't really think we need substitution for this. I mean, I'll show you what I mean. So the only inner function here, the only thing is there's just extra number there. So what I would do is I'd say, well, I know it's going to be sine of 4x. I know extra 4 is going to pop out. So let me put a 1/4 to fix it. And then I'm done. Right? Otherwise, you could do U-substitution. And then you say, okay, well, I don't want the 4. So I'm going to rewrite it 1/4. Cosine u du. And I'll write 1/4. Sine u plus c. And then I got to rewrite it back in terms of the original variable, 4x. Same answer, a lot more work. So if it's just an extra constant, I usually don't bother with it. Now, problem 2, I think, it'd probably be worthwhile in problem 2. So problem 2, you might rewrite this like this. And it might be a little more obvious what your inner function should be. I'm thinking you should be cosine 4x because it's the one inside of a power. So du equals -4 sine 4x dx. So you have the chain rule, you get that extra 4. Divide by -4. So this is going to be -1/4 u cubed du. And so it's going to be -1/4. And that's just power rule. U to the 4th over 4 plus c, -1/16. U is cosine. And we usually write it like this kind of lazy way with the little exponent there. But I think it's helpful to rewrite it like that to kind of see what really is going on more clearly. Next one, probably go for u equals 6 plus x squared. I don't think you guys really want to cube that, like do all the multiplication on that. Du equals 2x dx, which is good because we have an x and a dx. Don't want the 2, so that's going to be 1/2 u cubed du. It's going to be 1/2 u to the 4th over 4 plus c. So it's going to be 1/8 6 plus x to the x squared to the 4th power plus c. And that should be the answer. Number 4, and this one I think I could get away without the U-substitution. Like I know it's going to be e to the 6x. The extra 6 is going to pop out that I don't write. So we need an extra 1/6. Done. You could do U-substitution, u equals 6x, du equals 6 dx. Don't want the 6. So it's going to be 1/6 e to the u du. So it's going to be 1/6 e to the u plus c. You got to write it back in terms of the original variable. I don't know. I think those ones I would avoid U-substitution so much faster. This next one, U equals, a lot of times the whole denominator is what you want to go for. And some of you might already be thinking, oh, is this inverse trig, inverse tangent, inverse sine? Don't go there yet. Okay, a lot of times it's way easier than that. Some of you guys make it hard right away. So this is it. I mean, this is perfect. This is not inverse trig. Okay, this is going to be 1/4 du over u. This is going to be natural log 1/4 natural log the absolute value of u plus c 1/4 natural log the absolute value of 1 plus e to the 4x. So you do need the absolute values, but then you should always ask yourself for your final answer, do I really need them? Do they make a difference? This is always positive, right? So this should be my work, but my final answer, I want simplified. That's generally what we want. And so we're going to write without the absolute values for the final answer. It better be in your work. Now, if the inside was always negative, we get rid of them also and just put an extra negative in front to force it to become positive, like the absolute value would. Now we could try u equals 4x squared plus 9 du equals 8x dx, and this isn't going to work because we don't have the x. So that's not going to work. So we got to get more creative. I'm thinking inverse tangent, but this needs to be a 1 first. So I'm going to factor a 9 out. So that's going to be 4x squared over 9 plus 1. And then what's going to go here is going to be my u. So that would be 2x over 3. U equals 2x over 3. Du equals 2/3 dx. I don't want the 2/3. So I'm going to multiply by 3 halves. So I already have a 1/9. I don't care. And then I'm going to have a 3 halves. And it's going to be du over u squared plus 1. So it's going to be 1/6 inverse tangent of u plus c. So it's going to be 1/6 inverse tangent of 2/3 x plus c. All right. I'm going to just try U-substitution first. U equals 1 plus x cubed. Usually the denominator, what's inside the denominator. Du equals 3x squared dx. Perfect. I need an x squared dx. I got it. Don't want the 3. This means 1/3 du over u squared. This is not natural log. This is power rule. This means 1/3. Bump it up 1, divide by the new exponent, plus c. So it's going to be negative 1 over 3. U is 1 plus x cubed plus c. I mean, it's fine. You can leave it like that. I mean, if you want, you could write it like this. Don't forget the plus c. Next one, just try the denominator first. Du equals 3x squared dx. Perfect. Don't want the 3. So this is going to be 1/3 du over u. This one's going to be natural log. 1/3 natural log the absolute value of u. Better have absolute values. Plug back in what u is. 1 plus x cubed plus c. Can we get rid of the absolute values? Is this always going to be positive? Sure. Nope. It's going to be positive sometimes, negative sometimes. Final answer is absolute values. Number 9, we could try u equals 1 minus e to the 6x. I don't think this will work. U equals negative 6 e to the 6x dx. We need x to 3x dx. So now we get Now we have a 1, so this might be inverse sine, something squared e to the 3x, which we should also be thinking that's perfect. Because if that's our u, then du equals 3e to the 3x dx. And then with the 3, that's perfect. So I have a 2, and then a 1/3, and then a du over the square root of 1 minus u squared. So that's going to be 2/3 inverse sine of u plus c. So it's going to be 2/3 inverse sine of e to the 3x plus c. Next one, this one, don't make it hard, just distribute it. If it's a polynomial divided by monomial, just distribute the division, right? That's allowed. Can't do it the other way. So this is an integral of 1 plus 1 over x dx. So that's going to be x plus natural log of the absolute value of x plus c. Need the absolute values. Number 11, u equals maybe natural log of x in the denominator, and du equals 1 over x dx. Perfect. We need a dx over x. So this is going to be, now, by the way, this is a definite integral, so we're going to have to evaluate it when we're done. So this is going to be du over u, which is going to be natural log of the absolute value of u, which is going to be natural log of the absolute value of natural log of x. From e to 6, you need these absolute values. You don't need them around what's inside here because that was just what was given to you. So we're going to plug it in, natural log, the absolute value of the natural log of 6, minus natural log of the natural log, absolute value of the natural log of e. That's going to be 1. The natural log of 1 is 0. And natural log of 6 is positive, so we don't need the absolute values anymore for the final answer. It should be in your work, though. 12, u equals natural log of x would be my guess. It was 1 over x dx. That looks good. So this is going to be u to the 6 du. It's going to be u to the 7th over 7 plus c. It's going to be 1/7 natural log of x to the 7th power plus c. You cannot move that 7 out front because it's not a power on what's inside the log. So that log rule does not work. I could see some people thinking, oh, this is the same thing as this, or something like that, and I can move it in front. Cancel them out. And write this is my final answer. No, that doesn't work. That's it. Hopefully that refreshed your memory on those techniques and getting you ready to learn some new ones.